Yes. All right, so this video, we've already kind of went through a sine function and how we got those numbers with special right triangles and how it repeats a cycle every 360 degrees, right? Because like in a circle, we go around and around and around at 360 degrees each time. But now we're going to talk about how there's a 3 in front of the function, 3 sine theta. So that's what we call an amplitude shift. So I'm not going to do the whole table for you and go into the background. If you need to know about sine functions, you can look at my other video. But this is what a basic sine function looks like, correct? It would be 1 and -1 are the original amplitudes. And again, I go from 0 degrees to 360 degrees right here. So in this graph, the highest that it can go is 1, right? Because if you plugged into the calculator or did your special right triangles, you know that all those special angles like 90, 180, 270, it's all going to be 0 or 1 or -1. But if I multiply it with 3, then obviously 3 times 1 is 3, 3 times -1 is -3, but 3 times 0 is still 0. So here's what's important to know. So this is at 90 degrees right here. So at 90 degrees, it's at 1. At 180, it's at 0. At 270, it's at -1, or as close as I can get there. All right. So the points that are at 0 will stay at 0, but the ones, with there's a 3 in front, get multiplied up to 3. And the -1 gets multiplied down to -3. So my curve won't get wider, but it gets a lot taller. We stretch it. So notice how the peak of the sine function moves all the way up to 3, and the valley of -1 moves all the way down to -3. All right, so that is what the amplitude does. It basically, we call it a vertical stretch, but it stretches both peaks and valleys in this graph. And notice how the 0 stayed at 0. And notice how the graph doesn't get wider. It's still from 0 to 360. Okay? So, if I were to, let me draw another graph on top of here. So that would be 3. Let's say I did y equals 1/2 sine of theta. Okay? So instead of getting stretched all the way up to 3 and down to -3, so if 1/2 are right here, that means my graph would still start at 0, right? Because the zeros will still say 0. But my graph would only go up to 1/2, back down to 0, and this is -1/2 here, so -1/2, and up back to 0, right? So this is what we call a vertical compression because it's less than 1, all right? So that's what the amplitude does. It affects how we stretch or how we compress vertically. But the only thing that stretches or compresses are the values that aren't 0. So the 0 stays 0 because 1/2 times 0, 3 times 0 is 0. But all the other values in my table will either grow or shrink based on the number in front. So that's how you deal with amplitude in a trigonometric function.